Welcome to the Explainer. We're always hearing about AI doing these incredible things, but how it actually thinks, well, that's usually a complete mystery. It's a black box. And figuring out what's going on inside that box is one of the biggest challenges in AI right now. So today, we're going to pry that box open and investigate a really fascinating question. Can an AI build its own model of the world just by watching without ever being taught the rules? Okay, so let's start with a little puzzle. Imagine you have a super powerful AI, but you don't give it the rule book. You don't even show it what the game board looks like. All you do is feed it thousands and thousands of game transcripts, just a list of moves. Is that enough? Can it actually learn to play the game correctly? Well, to get to the bottom of this, a team of researchers set up an experiment, and they chose the classic board game Othello as their testing ground. It's simpler than something like chess, but it's still way too complicated for an AI to just brute force memorize every possible game. So, meet their creation, Othello GPT. Now, this model wasn't taught that Othello is played on an 8x8 grid or anything about flipping your opponent's pieces. Nope. All it ever saw was raw text, just sequences of moves like e6, f4, c3, over and over and over again. And here is where things get kind of wild. After training on millions of these games, Othello GPT could predict the next legal move almost perfectly. I mean, how perfectly? Its error rate for making an illegal move was an astonishingly low 0.01%. Just think about that for a second. It basically learned the rules of a pretty complex game without anyone ever telling them what they were. So this brings us to the absolute heart of the mystery. What's really going on in there? Did the AI actually develop some kind of internal understanding of the game? A model of the board in its quote-unquote mind? Or was it just an incredible mimic, a statistical parrot that had memorized patterns from the millions of games it had seen? The researchers basically had to become digital detectives. To solve this case, they had to figure out a way to look for evidence inside the AI's neural network. They were searching for a ghost of the Othello board, hidden somewhere in all those complex layers of computation. And their main forensic tool was something called a probe. You can think of a probe as a small, specialized scanner. They trained this little scanner to do just one thing: look at all the activity happening inside Othello GPT and try to guess what the Othello board looks like at that exact moment. But their first attempt was a total bust. When they used a really simple linear probe, the error rates were just awful. We're talking over 20%. The probe couldn't reliably figure out where the pieces were. It suggested that if there was a map of the board in there, it definitely wasn't a simple one. So this was a pretty big setback. Was the AI just a parrot after all, just mimicking what it had seen? Or was the internal map just hidden in a much more complicated way that their simple tool just couldn't find? But the researchers didn't give up. They just upgraded their tools. And that led to a huge breakthrough in their investigation. They switched to a much more powerful, nonlinear probe. And this time, they hit the jackpot. All of a sudden, this new probe could predict the board state with incredible accuracy. I mean, look at that, an error rate as low as 1.7%. The hidden map wasn't a ghost. It was there the whole time. So what this really means is that Othello GPT wasn't just processing a list of moves. In the process of learning how to predict the next correct move, it spontaneously built its own internal model of the Othello world, a complete 64-square board all by itself. And this image just illustrates so perfectly how real that internal model is. On the left, you see this jumbled mess of connections from an untrained AI. It's just chaos. But look at the right. The trained AI's probe shows this clear, grid-like pattern that perfectly mirrors the geometry of an Othello board. The AI literally built a map inside its own network. Okay, so they found the map. But that just brings up another really important question. Does the AI actually use this map to make its decisions? To prove this, they had to go from being detectives to basically running a sting operation on the AI. And the plan was incredibly clever. They would let the AI process a game, wait for it to build its internal picture of the board, and then, right in the middle of its calculation, they would reach in and surgically change the state of just one piece on its internal map. And just look at the result. It's amazing. On the left, you see the moves the AI thought were legal based on its original internal board. But on the right, after the researchers went in and changed just one white piece to a black piece on its internal map, the AI's predictions for legal moves changed completely to match that new, altered reality. It's like they performed brain surgery on the AI and literally changed its mind. The data here leaves absolutely no doubt. The number of prediction errors just plummeted, from almost 2.7 down to just 0.12 when they intervened. This was the smoking gun. It was conclusive proof that the internal world model isn't just sitting there, it's what the AI is actively using to decide what to do next. Now, this intervention technique did more than just prove their case. It gave them an unprecedented ability, a way to visualize what the AI is actually thinking about when it looks at the board and chooses a move. They created these things called latent saliency maps. It's a fancy name, but the idea is pretty simple. To make one, they go through the AI's internal board one piece at a time, flip it, and then they measure how much that single flip changes the AI's final decision. This shows them which pieces the AI is paying the most attention to. Red squares are high-impact pieces, blue ones are low-impact. And this is where it gets really, really interesting. On the left, we have an AI that was trained on totally random games. Look at its saliency maps. See how it only cares about the pieces immediately involved in making a legal move? But on the right, you have the AI that was trained on expert, championship-level games. Its view is so much more global. It's considering pieces all over the board, thinking about long-term strategy. So think about what this means. We've gone from just staring at a black box to something pretty extraordinary. We're not just guessing anymore. We can literally see the difference in the thought processes between a novice AI and an expert AI, visualized right there on the board. And that leaves us with a final, pretty provocative thought. This was all for Othello. But large language models today are trained on, the entire internet. So if a relatively simple game-playing AI is building a hidden world of an 8x8 grid, what other, vastly more complex worlds are today's massive AIs building inside their networks? And when will we be able to see them?